5. Okay, so tomorrow we're going to take our Chapter 5 test, and let's take a look at these. So number 1A, I've got 1A, I've got a 2x to the negative 2 cubed times a 4x to the negative 5. Okay, so what are my strategies when I do this one? Well, I'm looking at there's a lot of different ways to do it, but I'm thinking to take care of this exponent first. Take care of the cube first. This is 2 cubed, which is 2 times 2 times 2 is 8. I'm going to multiply exponents, negative 6, and then I'll bring down the x to negative 5. Okay, so the first strategy I did was took care of the negative 3 on the outside. I cubed the 8 and I multiplied exponents. Now I'm going to multiply whole numbers. I get 32, 8 times 4, and I'm going to add exponents. I get an x to the negative 11. As a better answer, I like 32 over x to the positive 11 because I like to keep it as positive exponents, okay, if I can. Okay, now thumbs up, thumbs down. All right. Let's look at B. Am I going too fast? If I get going too fast, will you tell me? All right, you do need to do that. Okay, on B, I'm going to do the same thing. I'm going to take care of this first. I'm going to take the negative 4 because it's on the outside, and the first thing I'm going to do is rewrite this. And I got to be a little bit careful with this. I'm going to make it a 5 to the negative 4. I got to be careful with that one. X to the positive 12 over this 15x to the negative 4. Now I got to be careful with the 5. The negative 4's got to go to 5. And then what is that? Well, let's move some exponents. Okay, I'm going to move them. If it's a negative exponent, I'm going to move it up or down. So I'll move this one up and I'll move this one down. So I'm going to have a 5 to the positive 4 times my 15. This x to the negative 4 comes up with my x 12. So all I did is if it was a negative exponent, I moved it, okay? 5 to the 4th is 625, but I'm just going to use my calculator. You can use my calculators tomorrow, not your phones. But what is 5 to the 4th times 15? It's just a big number. So I get on the denominator, I'll get a 9,375. 5 to the 4th, right? 5 to the 4th times 15. And then I'll have on the numerator, I'll have an x to the add exponent 16th. Okay, how am I doing? These are going to be the hard ones because the logs are easy. All right, C. All right, so one easy way to do C is to write it as 2 separate fractions. It really is. Because they're both being divided by 4x negative 3. So I'm going to write it as 8x4 over 4x negative 3 minus 4x negative 3 over 4x negative 3. Okay, so they are both being divided by the same denominator. So I just made 2 fractions. Well, now let's see what I'm going to do. I'm going to bring this up. And on my whole numbers, 8 over 4 is just 2. And I'll have an x to the 7th, okay? Because I brought the x 3 up, became an x positive 3. Now, anything over itself is just 1. Now, don't overcomplicate this. This is just something divided by itself, right? It's just something divided by itself. It's just 1, okay? How am I doing? Am I going slowly enough? Carly says yes. Tanya, am I doing okay? Yeah. Jose? Yeah. Okay. Vince? Good? Okay, now let's look at D. All right. D is a 5 to the negative 3 halves to the negative 1 half. Okay? So I'm going to multiply my exponents of a 5 to the positive 3/4, and that's the best I can get it. Or I'll take that answer. I would take that, or I'd go the 4th root of 5 cubed. Either answer works for me. Either answer works, okay? E is 2x to the 1/3 times x to the 5/3 plus 3x to the negative 1/3, okay? And I'm going to distribute this times this times this. Since I'm multiplying, I'm going to add exponents, right? So I'm going to get a 2x to the 6/3 plus 6x to the 0. Anything with 0 power is just 1, the number 1. So I'll have a 2x squared plus 6. How am I doing? Good. Good. Okay, now comes the easy stuff. Okay, we got through the hard stuff, really. That's going to be the hardest part of the test. What's that?
Did you do F?
I did not do F. Thank you, Carly. Carly, what's wrong with me? Everything, but that's beside the point, okay? Y to the negative 2/3 over y to the negative 1/3 minus 3y to the 1/3 over y to the negative 1/3. Okay, what did I do? I made it into two fractions, right? They're both being divided by the same denominator, so I just made it into, okay, so let's see. Gosh, I want to make this easy for you, okay? So I'm going to bring this one down and this one up, okay? I just want to make it, I know how I would do it, I just subtract exponents, but, so I'm going to have a y to the positive 1/3 over a y to the positive 2/3, okay? Brought that one up, make it a positive exponent, brought that one down, positive, okay? Minus 3, and I'll do the same thing, I'll bring this one up, so I'll have a y to the 1/3 times a y to the 1/3. So all I did is if it was a negative exponent, I moved it. Negative exponent, I moved it, okay? All right, now I'm going to subtract exponents. I'm going to have a 1 over y to the 1/3. 1/3 minus 2/3, right? Minus 3y to the 2/3. And that's probably about as good as we want to go. We could rewrite it. We could even do this. I would take this. I would take that too. Both are right. Both are good. That one or that one, okay? Thanks, Carly. All right, now here comes the easy stuff, okay? Same basis. So I'm going to look for your work. Don't use a log. Don't use a log. Same basis. Okay? Same basis. What's that mean? Well, 27 is the same thing as 3 cubed, isn't it? And 81 is the same thing as 3 to the 4th. Look how easy that was. So I get a 12x equals 4. Divide by 12, divide by 12. X equals 1/3. How's that? Same basis. Am I ready for B? That is 8 is 2 cubed, isn't it? 8 is 2 cubed. 16 is 2 to the 4th. And 4 is 2 squared, okay? So I change everything to same base, base 2. Here's my 8. There's my 16. There's my 4. Now, when I multiply, I add exponents. When I multiply, I add exponents. So I'm going to have a 2 to the 3x equals a 2 to the 16 plus 2x. Okay, think about that. Oh, you're going to have to know that kind of stuff in calculus, aren't you? That kind of stuff right there. Mm-hmm. You're going to have to know that in calculus. That kind of stuff in calculus right there, right? You're going to have to know that. Okay, now same base, right? So I got a 3x equals a 16 plus 2x minus 2x minus 2x. X equals 16, okay?
Doing that, but with the natural log and E.
Yeah, yep. Okay, C. Am I going too fast? Now, before I do C, I'm going to do a little side work. 1 over 9 is the same thing as 1 over 3 squared. You okay with that? which would be the same as 3 to the negative 2, okay? So see my 1/9? All right, 81. 81 is the same thing as 3 to the 4th power. 3 times 3 times 3 times 3. And 1/9 is the same thing as we know right here. 1/9 is the same thing as 3 to the negative 2. Okay, same base, same base. I've got a 4 times a 1 minus x. Now it gets easy. Negative 2 times a 2 minus x. Right? I got rid of the bases. Distribute. Let's distribute. 4 times 1 is 4. 4 times a negative x, a negative 4x, equals. Negative 2 times 2 is negative 4, plus, because negative times negative, plus 2x. Okay? All right, now it's getting easy. All right, I'm going to go plus 4x, plus 4x, plus 4, plus 4. So I've got a 8 equals 6x. Divide by 6, and I think I get 4/3 when I reduce it. Okay, that was a little bit harder, but I have faith you can do it. Right? Okay, 3. All right, to do 3, we got to go back to what an exponential function is. So 3, I'm going to have y equals ab to the x. Let's just start right there with number 3, okay? All right. All right, so I've got a point 0, 5 and another point 3, 40. All right, I know a is 5. I know a is 5, but I'll prove it to you. You guys okay? The value of a, the beginning number is 5. But we can do it. We plug in 0, plug in 5. So we have 5 equals ab to the 0, and anything to the 0 power. So I put that in for y. I'm sorry. Put that in for x, and then for y. So then 5 is just equal to a, right? Because anything to 0 power is 1. Now let's rewrite it. I got a y equals a 5b to the x. So if we want to find b, let's put 40 here and 3 in for x. So 40 in for y. And 3 in for x, right? And let's solve. Okay, that's easy. Divide by 5, divide by 5. Cube root. So the value of b, or the base, is 2. So I have an answer. I know a, I know b. Let's write it like this. Y equals 5 times 2 to the x. Let's see if I can make a scene. I want to make sure you don't do this. Please don't do this. Please. Please. Don't make that 10. Don't do that. Don't do that. That's 2 to the x. Is that 10 to the x, is it? You have no idea how many kids do that. Like, oh, it's not the same. Okay, there, did I make a big enough scene? All right, whatever it takes, right? Whatever it takes. Okay. All right, probably the easiest question of the whole test. Here it is. Seriously, what's the half-life? That's the half amount, but what's the half-life? Half-life is a time. It's 6 hours. Because you go from here to here, right? So 1,000 to 500 is half, right? How long will that take? 6 hours. So the half-life is 6 hours. It's that easy, okay? Everybody see that? Now the equation we need is our y equals ab to the t over c. And c stands for the cycle of time, right? So we're going to go y equals, we start with 1,000. I know that, right? 1,000. It's a half-life to the t over 6. There's my equation. How am I doing? Now, let's use our equation. Let's put 17 hours in it. So I'd go y equals 1,000, 1/2, 17 over 6. Let's see what my calculator says. Clear. 1,000 times 0.5 to the 17 divided by 6, right? I get about 140.3, I guess, kilograms, right? Wasn't that easy? You guys agree? We should get that one right tomorrow, correct? Okay, turn the page. All right. 5. Now, you cannot use your phone. So how are we going to graph this? How are we going to graph this? You can't use your phone. You can use my calculator, right? Can't use decimals. What would you do? You don't have decimals. What are you going to do? What do you do? Okay, you can use my calculator. My calculator will do it. But we can always plug in some points. Worst case, right? Worst case. So if we had to plug in points, what points would you pick? What are the easiest numbers you could think of?
0, 1, 2.
Yeah, how about even 3? Totally. So let's let x equal probably 0, 1, 2, and maybe even 3, okay? So you can graph this on my calculator, but if you're not sure how to do it, let's just go 10 e to the, let me use the other calculator, not the old one, clear. Let's go 10 e to the negative 0.4 times 0, right? Right, Carly? And I get 10, so I get a point at 0, 10. Okay, let's plug in 1. 10 e to the negative 0.4 times 1, and I get a 6.7, so I get a point at 1, 6.7. Okay. All right, let's go. 10 e to the negative 0.4 times 1, right? No, 2. 2. And I have about a 4.4, so I get a point at 2 and about a 4.5. Okay, let's go 3. Why not 10? And we'll go negative 0.4 times 3. So I get an answer of my 3 and about a 3. Okay, so that might be enough to graph it, right? All right. 0, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, let me use a different color. I like colors. I got a 1 and a 6. 1, 2, 3, 4, 5, 6.7. 2 and a 4.5. 1, 2, 3, 4.5. A 3 and a 3. Now, is that enough for you to get the general idea? What do you think? Is that enough? So I think it's going to look like this. What's going to happen? Come on, smart guys and smart girls. What's going to happen here? What's going to happen?
It's going to go down, but not all the way down.
Yeah. It's not going to cross the x-axis. That's a lousy looking shooting there, right? Anyway, so, and you need to do that, okay? You need to put this. In fact, I want 3 things. That's all. The 3 things are this. I'll show you 3 things I want. I want the y-intercept. Okay, see it? I want the y-intercept. I want the shape that's going down because it's decay. And I'd like to have an asymptote in here because it has a horizontal asymptote, doesn't it? Right? Perfect. Okay, can you do that tomorrow? You just have to plug in points and graph it. That'll work. All right, now domain and range of this graph. Well, that's easy. What's the domain? Yep, domain's all real numbers. Everybody agree with Kai? I do.
Yeah, greater than 8 for range.
Yeah, and then range is y is greater than 0, but not equal to, because it never touches that line, right? So don't put an equal sign here. No equal sign, okay? Just greater than, okay? Thank you. Nice job, Kai. All right, now, you're going to need these formulas. Make sure they're somewhere, okay? We need A of t equals P 1 plus R over N to the NT. And we're going to need this formula. A of t equals P times 1 Oh no, my bad. PE to the RT. There we go. You're gonna need those two formulas, okay? Bank A. Shall I wait for you? I probably need to wait for you, right? We'll do Bank A. Annually. So if Bank A is annually, N is 1. All right, I'm going to put in 20,000 for 5 years. So Bank A is going to be A of 5, because go for 5 years. I'll go 20,000 times 1 plus 0.045 over 1 to the 5 times 1. Okay? I don't need the 1. Do you guys agree? I don't need the 1. So I'm just going to use my calculator. 20,000. 1 plus 0.045 to the 5th power. Can I get an answer of $2,493.64? Okay. Make sure you guys want to try it. Make sure you get it in the correctly into your calculator. Just give it a try. Okay. Make sure you do it. Everybody do it. Anybody want to borrow a calculator? Anybody need to borrow a calculator? Everybody have one?
I'll take one.
Okay, there you go, Vince. Make sure you can do it. Make sure you get the same answer I got, okay? Okay, everybody get that answer? Okay, now, next one. We're going to do it quarterly. So N is 4, okay? Quarterly, N is 4. So 1 plus N is 4%, 0.04 over 4 to the 4 times 5. Okay, so make sure you guys try this one too. Make sure you get the right answer. Because sometimes kids
Can
will...
you move your header? Thanks.
Yeah. Yeah. Okay, 20,000 times 1 plus 0.04 divided by 4 to the 4 times 5 power, okay? Okay, I want you guys to try this one too. Make sure you get the right answer. 24,403.80, okay? All right. Everybody get that answer for Bank B? I'll wait for you. I want to make sure you can get it because you got to make sure you can use the calculator correctly. Carly, did you get it yet?
How did you get there?
Okay, let me see.
No, I got this.
Oh, you have 4.5, 4 times 5.
Oh,
Or just
4
make-
times
Or just
5.
make it 20. Just make it go straight to 20.
Oh,
right?
okay.
Oh, I put 4.5.
Yeah. That's supposed to be a times.
Oh,
five,
yeah,
right?
it looks like 0.5.
Oh, sorry, you guys. It's 4 times 5, okay? Try 20. Just try 20, okay? Just make this a 20, because it's 4 times 5. How's that?
So is the top one just 5 then?
Yeah, just plain old 5. Yeah, it's just plain old 5. 5 times 1. And then Bank C when you're ready, and I'll have it done. A of 5 equals 20,000 times E to the 0.038 times. How's that for times sign? Times 5. Did you get that answer? Okay, here's the last one. Since we're going to compound it continuously, 20,000 E button 0.038 times 5. And I get an answer of $24,184.99. The E button is right there. Do you see it right there, Greer? Okay, right. Yeah.